Hi everyone. Book. Hi everyone. So welcome back to our book reading club. So what I've been doing is actually I was reading the book and I took a look at notes. I typically, when I read, I downloaded the EPUB version of the book, and on my phone I have the EPUB reader. So I was reading it from my phone and then I was taking notes. Because there are some graphs and listings, eventually I figured out that the phone is not the most convenient way of doing this. So I'm curious also to see to know how you read it. I know some people have ordered the printed book. I don't have the printed book, so I was just reading it from my phone in bed because with laptop it's not really convenient. And I was taking notes. Mm, so probably the next chapter I'll read it from a tablet because I think sometimes for me it was difficult to I wanted to see the pictures, I wanted to see the code from the phone. It was not easy. But as I was reading, I was taking notes. So at the end, this is what I was doing today. So let me share my screen. So what I was doing today is I used ChatGPT to just take all these pictures. So I took all these pictures of all these notes and I asked ChatGPT to turn it into handwritten notes. At the beginning, I sent it the book, I sent it the notes, and what it did is just took a summary from the book, like it wasn't really my notes. But then I said, hey, like it doesn't really look my notes. Can you please do something um, make it real? So then it turned, where is it? I think it already looks more like my notes. I don't know. Yeah, I said you added too much. Hmm. I think ChatGPT is funny today. I think like half the internet is not working. I don't know why. But yeah, like then I said you added too much to the notes, and then it created proper notes. And then I don't know if any of you, I see that some of you are also using the website. So three other people. I don't know if any of you are on the call today. So I started putting the notes here too. Uh, so these are my notes. So what I did is because we can get an API token, and then with this API token, I put the notes. But since other people they didn't make their profile public, I don't know what is uh, like what exactly they did. So did anyone on this call actually use the API?
No.
No. Hi, Chandra.
Hey.
Um, okay, so I see that we already have more people than at the beginning. So I describe what I did. Maybe also every one of you can tell us how it went. So I finished reading the chapter number 0, chapter number 1, and chapter number 2. Chapter number 2 I finished right now, like I don't know, 10 minutes ago. I skipped most of the image related stuff because I thought I don't know how relevant it is, and there is a lot of things I need to really understand. So I thought like for this image gen, I just go through this quickly without really going deeper. Um, so yeah, how did it go to like if anyone wants, you can just unmute yourself and share how it went for you.
I mean, I can share.
Yeah, please.
I felt like in model they expected you to know some of the math because I think they started just using the terms.
Yeah, it
So if
was too
you,
much, right? Like you
yeah,
just read, you understand, and then boom, and it's like nothing makes sense
yeah,
anymore.
yeah. So like, I mean, no idea about what logits is, and then suddenly um, I mean, I knew in my head what it was, but some of the sentences like just they're assuming that you know. So I think for me. I don't know. I might read it again. A lot. Yeah, chapter two is definitely like a. I just went from like, yeah. 1 plus 1 is 2. 2 plus 2. And now we'll talk about differential equations.
Hmm.
Okay. So that was my. So what I've been doing is I think I am underlining sentences that I don't know why the what is it? The author is making those assumptions,
Hmm.
and then I'm going to take those lines and put them in Claude and understand. Hey, what is, uh, why are they saying this? Is I think my that's what I'm trying to do. Like I think for me at least, page 45. There's the problem for multi-layered neural networks because a series of linear layers, such each one a matmul, would collapse into a single layer with all of the matrices multiplied together. I'm like, okay, yeah, that's a lot of math. I need to understand why that happens. So that's my experience.
Maybe I'll add that like I studied these neural networks. I was taking some classes previously, but still, like I didn't really learn attention and other things. So for me, it was also a bit too much. What helped for me personally is I took the EPUB, I uploaded to ChatGPT, and I asked ChatGPT, "Hey, like here."
Mhm.
So I did this for this arithmetic intensity.
Mhm.
Like, okay, what do they mean here? Like how this thing works? And
Yeah.
then, like also for attention, they say, okay, attention is quadratic algorithm, but then because like for every step, you need to compute every step depends on the previous steps, right? And then you have this key value cache that helps to turn it from quadratic to linear. And I was talking to ChatGPT, hey, how exactly does it look like? Where
Mhm.
do we do what kind of calculations? Like, how does it look like? I think this AI was really helpful for me personally to fill these gaps that the author
Mhm.
just assumes I have. Like
Yeah.
they
Yeah.
assume that I have this knowledge, but some of it is rusty, some of it non-existent. So like I had to fill these gaps by talking to ChatGPT, and for me personally, it was very helpful. I don't know what like if anyone else did something similar.
Yeah. I'm curious too.
Can I go, Alexi?
Yeah, of course, please.
So initially, I started reading the PDF, and then I started taking notes. Then I realized maybe I should use LM Notebook LM rather, the Google one, and I it did a decent job of generating the talking points and things like that. But I do agree. Oh, before reading that, I was trying to analyze like how was this book written. So if you guys research a little bit. The author initially used AI to write this book.
Hmm.
And then I think he was questioned a little bit, and then he went back and did some handwork, like he did it manually. So maybe that is why we feel that it suddenly jumped from, like a novice level to intermediate, like in the second or third chapter. Then back to the notebook LM, it did an amazing job of like, but it went very technical. I do agree with you guys. Actually, I'm attending a workshop at Stanford on what is the title? Modern RNNA architecture. It starts from, all the way from CNN to the current transformer architecture workshop. So I think subconsciously it kind of everything made sense. It's not that don't ask me questions right now. What does it mean? But I'm just saying that it made sense. So it was a good opportunity for me to piece things together. But then it jumped like really quick into like an expert level. At that point in time, I just stopped, and actually I haven't done the formulas yet, which I'm hopefully I will do. The back to LM Notebook, it did an amazing job, to be honest with you. It gave me all the formulas. I think that is my best companion. I did try ChatGPT too. I did try Perplexity, but I keep going back to LM Notebook. So that is my. Maybe I might go back to Claude. Who knows? There are too many options. So I
Hmm.
think one has to stick with one that works for them. Whatever your thing is.
I think with ChatGPT, the problem is that the verbosity for me, like sometimes the output is just too much. Like
Yes.
I wanted to answer one specific question, but then it goes like, here is like
Yep.
4 screens of text.
Yeah.
And then I'm, oh, hey, slow down. This is not what I needed. Like I needed just 10% of that. So does Notebook LLM have this problem?
So no notebook, no, it
Okay.
doesn't. I think it is very brief to the point. I mean, you can dictate it, right? Like you can basically say at what level you want it to,
Hmm.
regurgitate the information back to you. It does a decent job. On that note, I would say Claude does an amazing job of being concise. Like it's just like single page, you get everything you want to know, and then you can ask it to break it down. I think Perplexity is kind of in between ChatGPT and Claude, I would say. And the reason I use LM Notebook is that I like to see pictures and diagrams, so which you can generate through mind maps and trying to remember you can generate PowerPoint. So it's like you got different tools to use. So in
Hmm.
LM Notebook.
Um, yeah, thanks. Anyone else wants to add something?
I can go.
Yeah,
The
please.
0 and 1, they felt like normal, like advice is like when do you like in normal software, when do you use a vendor, right? Or when do you build your own, or when do you go on-prem? Those when do you use microservices? Don't start off with microservices. It's similar to as like don't start off with having your own inference infrastructure. Just rent it till it goes to like a certain point, and then you can start using it. So I found that interesting, like that, like it just mapped one-on-one. But yeah, I think chapter 2 was a bit of a jump for me, so I think I'll need to go back for that one.
I have a question for Chandra because I know you read a bit more.
Mhm.
So I also have this feeling, like a review shared, that perhaps I'll need to go back, but I'm also wondering to what extent I will need to go back because, like, some things I skimmed through, like for example, this
Mhm.
image generation stuff.
Mhm.
Some things like were very dense, and for me, like, I just have a mental note, hey, I probably should come back because I don't think I really understood these parts. But then for me also. I know that there is this trap of going deeper into something, but then never needing it in the future. Like, in the future for this book specifically, I mean, like in the coming chapters, like after chapter 2, how often does the author go back to these concepts? Like, do we really have to know them like super well to understand the materials? Or just conceptually, okay, this is what it is, and we don't really need to know it in and out?
I mean, I'm going to hardware.
Hmm.
So if you go back to the first diagram, right? Like I'm trying to see in chapter 0. Remember, he says the runtime and infrastructure.
I think so.
Um,
I'll share my
and,
screen now.
um,
So this is chapter 0, this one, right?
yes. So what would be good if you are again? I'm not that ahead, Alex. I mean, probably in chapter. I'm thinking right now I'm in 4. What would be good is to figure out which ones you want to learn.
Hmm.
Um, and even if you just learn the part of it, the model performance techniques helps a lot with applied AI, right? How do you make something faster? And then infrastructure in terms of some of the concepts like routing and stuff. So look at this diagram, see where you want to go, and then you can start skipping. If
Hmm.
you're not interested in going to the CUDA layer, then skip that topics.
Hmm.
But be very clear about what you want to do. My opinion is the VLLM definitely, I think, is a very good thing to have from a, I think, next level perspective. I don't think a lot of people will go to the CUDA layer. Maybe it's not worth your time unless you're really interested in it. So we
Hmm.
can skip some of the CUDA discussions. Uh, Coming back to, I feel like chapter 3 is something that we should spend a little bit more time on because that seems to have a very good how inference works and stuff like that, because it also talks about why LLMs exist and what needs to be done. Hardware we can skip and we can directly go, I think, to again, I'm assuming this, to techniques in 117. Even if you don't take a look at the part, I mean, even if you don't understand what GPUs work and you have an idea, you can still understand what we're trying to do with the software. So that's my opinion. And I think I also wanted to point out, we are probably going in the right direction, because I don't know how many of you heard the news that Claude is going to watermark.
They already do, no?
No, so they're putting it to all the models where, and I was like, how do you watermark LLMs? And they had a very interesting blog post. And if you guys want to, I think if you go to page in models, I think it is figure 2.6, top K and top P, I think.
What's the page number?
It's chapter 2.2, inference mechanisms, and specifically section 2.2. Page number is, I have a book, sorry. It's 47.
I think here, right?
Yes.
Max tokens, yeah.
Yeah,
that was
so,
actually, yeah, so this one, I didn't have any problems with understanding this one.
Yeah, but I was able to
Pretty straightforward, yeah.
I was reading this, and then they came out with an article of how they're doing watermarking, and I think that helped definitely understand. So I think it's good that we're reading Inference.
There's a very nice article from
Yeah.
Sebastian Rashka. I don't know
Yeah.
if you saw. This is his assumption, right? So he doesn't say that this is exactly how it works, but then it says, yeah, usually we sample with top K to top P sampling, right? And this is exactly what this book is talking about here. And then he explains how it works. So I'll, in case you didn't see this, I'll share here in the chat. I think this illustration was really clear to me how exactly this watermarking works. I didn't read the book though.
No, I was saying the concept of top K or top P is now where they're discussing in that chapter, right? He talks about, so if you scroll a little bit down, I think right below that image. Yes, there it goes. Okay, so what happens with top K and top P, and how are they using that to do the watermarking was a very good. Oh, and now I got an overlap of, because I read this and read it a bit more, definitely helped. And Claude also released, I think, their version of how they're going to watermark, and I think Sebastian Rashka is pretty close to. I shared that link, so again, just encouraging us for us to. It might be difficult, but I think this chapter, getting better, is definitely going to help us in, I think, the future ones. So. Basically, what I was asking Alex was, I read it, I came back, and I think it's still not, because I skimmed the first time. I was wondering if we should spend maybe a couple more days on this chapter, is what I was going to propose.
Models?
Yes. But if not, it's good. Yeah, I'm gonna try to.
Yeah, I'm just thinking like some things are really concept dense, right? Like towards the end of the chapter, like first half is for me was okay, but then it was like, okay, well, what's happening? Like why it's so complicated? Like especially when they started. Okay, so this part I didn't really go into details, but then they started to he started to go into this inference bottlenecks. And then talking about this arithmetic intensity, and this is like a completely novel concept to me because I didn't really work with GPUs before, and CUDA and stuff. Like for me, it was like, wow, so much information here. And also, I don't know much about attention. I only know that it exists. But I wonder, so maybe it makes sense to just continue, but then if some things are actually needed, in the future, like in the future chapters, then we go back and we revise some of these things. Would it make sense?
Actually, I think that makes more sense, Alex, because then we'll never move the chapter. It's always better to go back and then say, oh, I think I missed a section in the previous chapter, which I need. and then we can come back. Yeah, I think I like that idea too. That actually helps us move forward. So I'm good.
And sometimes I just ask, not specifically for this book, I haven't done this yet, but sometimes I just ask ChatGPT, hey, explain me like I'm 10, or like explain me like I'm 10. It doesn't always work because then it starts talking about, I don't know, toys and stuff, but then like explain me like I'm dumb or something. Like explain me like I'm a non-mathematician, right? So then it helps it to give better answers. And I ask you, hey, can you give me a different analogy? And then like after it gives a few analogies, then it makes sense. So maybe this is something you can also try using if you haven't tried this yet. Okay. Anyone wants to talk about like particular topics we covered? Maybe something was not clear, and we can then now together discuss these things.
Hi, I can share something.
Yeah. Hi.
Okay. Hi. Okay. This was very interesting for me to know that I have been studying and knowing that, okay, how matrix multiplication happens and how the regularization happens in CNN. Even I have, when trained CNN, never thought that, okay, how matrix must, after each step, why do we use like the regularization that makes a kind of a milestone of knowing one feature, and then that stops kind of there, and then the next feature starts from the ending point of the previous multiplication, and then it makes kind of sense, because there was a line that if you just don't use the regularization and make all of the multiplication happen, so it will just dump everything in the end result. So that was something very interesting, and I believe this book is kind of it tries to cover all the topics, like maximum topics. So if someone is practicing, they will know end to end. I believe the person who has written this, he wants to make everyone know everything from 0 to maybe 1, like from 0 to like the maximum information. So I'm really happy that you suggested this book, and I'm like reading this.
Okay. Did you finish the chapter 2? Or you're still
Yeah, I finished. Yes, I finished the chapter. 0 and 1 was like, yeah, as everyone else has told, shared the experience, and chapter 2 was kind of, but again, I used the same method as you guys did, made it Claude and GPT to make me understand.
How are you taking notes? Maybe it's not a question just for you,
Okay,
Samira, but for everyone. But
yeah.
for you specifically too.
Okay, for me, I'm very comfortable with pen and paper, so I'm taking it. But as the notebook has been shared by, there was someone who shared that notebook is very good, so I may use that for the next chapters.
Because I also use pen and paper. The problem with this is navigation and indexing and trying to go back to what you wrote before and find the information you need. Do you have this problem or not really?
Yeah, I think I don't know, but when I write something, I kind of understand it better than typing
So you
it.
don't use the notes anymore after that?
After that, I sometimes do visit them, but that makes me more like, in my mind, things become clearer when I
That's
write them.
same for me. Yes, yeah.
Yeah.
I basically write in the book, or I write in. I take a printout, and then if it's much bigger than what the book is, then I have like, okay, in my notebook, in like it's 1.1 or something like that, and I kind of link it to the more expanded one, because then when I reread it, I can immediately go to that section and understand it. So I like writing in the book itself, like my thoughts and stuff. So that works.
Mm-hmm.
Do you use sticky notes,
No,
Chandra? No?
because they started. I read it so much that sometimes the sticky note comes off and it goes
Okay.
somewhere else, and then I'm like, I don't know where this one goes now.
Right.
So that's why I underline and then I write my thoughts about there, like in my own version. I draw diagrams, but if it's much bigger from that, then I go to the a page or something like that. But
Mm-hmm.
yeah, I agree. Writing and drawing. So that's why I shared another book, Alex. I mean, I'm reading. I think she wrote and you don't need to buy the book. Just read her blog because I feel like she also thinks in the same thing, like diagrams and writing and stuff like that.
Mm-hmm.
So it's very good. From oh, somebody sent a nice. Oh, your brain on ChatGPT. Cool. I'll read it.
Yeah, thanks.
Dishan, you were saying something about um, forward and backward pass and stuff. How does it relate to this chapter? Do you think that we should spend, like, what is your impression, or is it something
No,
that you were just
actually,
thinking about?
yeah. Hi. So actually, I have done kind of a little inference engineering course earlier, and that is where this is kind of a, so that was a very fast and quite intense. So a lot of topics did sink in, some of them did not. So I'm kind of recapping. So now, basically, I have actually not completed these chapters per se, but I mean, I'm talking generally that a lot of these topics like quantization, which will come, and how memory. So basically, these forward pass and backward pass store these activations, how they store these weights and gradients and all those things. So I mean, at least a bridge between those topics to this inference engineering will help, because that is how the memory gets constrained. And when we say memory, there are actually two memory where we are talking about. One is the storage memory, which is the HBM RAM, which is the place where everything needs to be pulled in from. And the other we are talking about is the memory bandwidth. So what is the limiting factor? So these are the two things. I mean, how much memory can you actually pull in at one go? So and put it into your GPU,
Mm,
so I mean, that is where this roofline model comes in, right? Where, I mean, a part of it is CPU bound, and a part of it is
memory.
not GPU, sorry, compute bound, and other part is memory bandwidth bound. So it is not memory storage bound, it is memory bandwidth bound. So those are the things, I think, which will really help if we go deeper into how the neural network uh, stores in things in their forward pass, and what it computes and stores in during the backward pass. And those states actually get stored on your memory and do of to and fro between the GPU, CPU, and the HBM memory. So that is one, and the other is the transformer model, and how the I think the you also talked about those logics part. That is the very end part of it, how it detects, how it predicts the next word. But a lot of compute happens during the attention mechanism, which they're talking about the quadratic in nature when they calculate the QKV matrices, and how that
Mhm.
works is very central to the idea of the KV cache, why KV cache is needed, and how KV cache is preserved, and between requests, between a single request and between multiple requests. So it has a role to play in both cases. So that's why I just talked about those concepts.
Mm-hmm. Yeah, thank you. Because I was like you were mentioning this compute bound and memory bound, and it was this chart with like they showed the bounds.
Yes, that's
What was the
very
name again of this thing?
roofline model. Roofline model.
Roofline. So
That's very
you
central.
would recommend to revisit it, right?
Yes, absolutely.
Okay, because for me, like it was the first time I heard about this concept, so I kind of just skimmed through and thought, okay, like I kind of understand, but I don't really understand. Like if you ask me to explain it, I will not be able to do this. And I thought,
if you really want to go into the inference engineering stuff and understand it, that is key area, and that arithmetic intensity is actually a very exciting concept. Okay, so that arithmetic intensity actually talks about whether operation. So basically, a matrix multiplication is just multiplication plus addition.
mhm,
Okay, two things multiply, then you add something. Okay, so that is a basic thing which can be hard coded in a GPU. Okay,
mhm,
so if you bring down something to that level of simplicity, then it's very fast, because GPUs are very fast at parallelizing that operation of doing multiplication and addition. Okay, so to bring it to down to that level, uh, now there are different kinds of problems. So some problems are arithmetically intensive, where which are good for GPU, and GPU are good at that. So if you find such problems, metric multiplication is one such problem, where you can do large matrices, and GPUs can compute it in parallel, and it will be very very fast. So in that case, it is compute bound. So the more the compute you have, the better you can do it. But there are some problems where you have to bring in a lot of stuff from the memory to the GPU, and then your latency depends on that, not exactly GPU, because your GPU is starving for data. GPU actually needs a lot of data to compute it parallelly, but because it is starving, because there is a lot of overhead in bringing that data from your high bandwidth memory into the GPU. So those processes are memory bandwidth bound. So that is where, the whole play lies. Actually, you say, if you how do you separate, how do you optimize that, and the prefill and the decode part of the inference, how they are, one of them is prefill, compute bound, and another is the memory bandwidth bound. Yeah.
yeah, thank you. So you summarized it very well, and I think I understood it a bit better after
Yeah.
you talked about, and then Chandra, I think you mentioned, yeah, so it's here, this roofline chart. And then they were saying that some operations are compute bound, some of them are memory bound, and then he goes into saying that so prefill, this is like a just matrix multiplication, right? So this is compute bound, and decode, which is token generation, right? So this is memory bound. So I think it was a very nice summary. Thank you.
No
So for
problem.
me, this concept was like not super. It's still not super clear, like because like there are so many new terms for me. But I hope as we go along the book, sorry, it will become clearer.
Yeah,
I
the
would like
matrix
to.
multiplication that is happening is actually the KV cache multiplication at the
Hmm.
in the decode stage. So that KV cache needs to be brought in every time. So that is the thing, and that
So if
KV
I'm
cache is a very central concept to the transformer model.
so let me see if this visualization design is basically what you're saying is you calculate something, you put it in the cache, then you calculate something, you put it in the cache, but at the end you need to bring all that cache together. When you're doing the calculations, that
No,
is
other
very
way
highly
around.
computed. Oh,
Uh,
other way around.
it's
Okay, go ahead.
Yeah, you how first time how you bring in something. And yes, obviously it is a so actually PyTorch and these things have a graph. Okay, how do you compute things? Okay,
Right.
and how you compute things is it's a graph, right? And how that graph, how much of that can be put into the GPU, that is going to bring you performance and low latency. And how
Right.
much of that graph is going to require you to move to and fro between GPU and CPU, that is going to add to latency. And wherever you have to bring in something from memory to again your CPU, or again from memory to your GPU, that is again going to bring more latency. And then there is a third tier of other storage out of memory, so that is the slowest, like, as you know, IO, right? So that
Gotcha.
if you are going to do that, that is again going to add much more latency. So your goal ultimately is to reduce latency, parallelize things as much as possible, and and your GPUs should be always working, and that is the aim. Your GPUs should always have enough data to crunch, so that you are always compute bound and not memory bound. That is the first goal, actually.
Got it. Got it.
Mhm.
Okay. So you have like a Ferrari, but if you're not giving it enough or whatever, you're just wasting the GPU because you're trying to give it more stuff, kind of thing.
Exactly.
At least in my head. But okay, I think now I can, because for me, I was always, when it comes to LLMs, I kind of combine GPU and CPU into one thing, but they're completely different things. You have the CPU, you have the GPU, and then you have the memory. These three are in play right now. I think that is an insight that I'm going to take.
Yeah, and the memory, again, that is the memory bandwidth, which is like which is kind of constrained by the GPU provider, that how much memory
Right.
can you put in. It's not about storage, that how much memory can you store on the HBM. That HBM is the high bandwidth memory, which is the storage part of it. But then when we talk about the roofline model, we are actually talking about the to and fro of the memory, not the storage part of it.
Yeah, like you have a highway, which is your GPU, which can have like 10 cars. But if there's only one lane going to that highway, you're wasting the four other three lanes because you're only using this one lane, is the visual image that I have in my head. But that's okay. I think that helped definitely. Thank you, Dish.
Thank you.
I have to add, the more I listen to everyone talk, this everything all you gentlemen and Samina and everyone discussed is not a new concept. These are fundamental software engineering principles. I mean, you need to manage your memory, you need to manage your compute lifecycle, you need to see how much time it takes to read the data from, let us say, disk drive or any storage to memory. For old school people like me, it is very refreshing, and I'm very happy to see all this discussion. And but back to this conversation about what we need to focus on. If you may add, I think we need to, at least for myself, I need to go back and look at page attention, all the attention mechanism, and the math behind it. Two of the sources that I would like to share with the group here that maybe most of you are already aware of, as to how you practically visualize and how do you do the math and how do you see the results happen. I think this YouTuber, her name is Arohi, Aarohi, and the other, he's a MIT PhD dude. He runs the program at Visuara, and he's also pretty good. They just break it down. So, like, you will never forget the concept once you listen to the YouTube podcast and then try the math and the labs they have. It is extremely efficient. You don't have to read like 10 articles to understand one concept, in my opinion. So I would strongly suggest that you guys give
Can
it
you
a
send
try.
the link? Or I
Yeah,
didn't
yeah,
manage to
I will.
catch the names.
Yeah, I
Can
will. I will post the link. Yeah, I will do that.
can we share it on? I think I'm gonna get to the habit of maybe sharing it on Discord, because Alexi, if you close the Zoom, I don't know how to get back to the links
Yeah, so
necessarily.
what I will do is like last week, maybe this is not something we talked about, but last week, where's past events? So we have actually like
Just
there
oh,
should be
post.
here's the article. Yeah, so there is an article from what we did, right? A summary. Let me share it with everyone.
Does it have the links in there? I didn't know
Yes,
this.
yes. So these are the sources we talked about.
Oh, perfect. Okay, awesome. Yeah, I think I'm gonna.
Yeah,
Thank you,
so like I'll
Alexi.
create
Yeah.
a similar summary. And can you say it again?
Oh, sorry, I was just trying to find the link and it started playing.
Oh, okay. I thought somebody was speaking. Yeah, so I will do it in the same way. So this is AI generated, right? So I didn't really check it. But what I did is that I took the transcript of what we talked about. I took the chat, the history of Zoom. I asked Claude to put this together into an article, right? So I think, and then I skimmed through this. Like it looks like everything we talked about is here. So I want to do something similar with today's discussion, right? And perhaps I'll see if we can add any pictures like for this roofline model too, because I think we had a very nice discussion. Would be pity if we lose it.
Okay.
So this is the video. Arohi. I don't know her. Well, thanks for sharing. So then here, I guess she talks about the internals of LLMs, right? No.
Yeah, I mean, this is only a sample. Yeah, so like every video of hers, she goes through the simple math. Like you could be in college attending that, like just trying to understand what matrix multiplication, that is sufficient for you to listen to her tutorials. Very, very fundamental, easy to follow, but you need to be patient. You can't skip and, just try to come back and all that. If you're committed to the program, then this is very, very efficient and productive.
Thank you.
You're welcome.
Okay. Do we want to talk about anything else?
Actually, I want to just ask something because I have faced a problem. In my company, I was given a task to make an application of tender monitoring. So for the tender monitoring, I have to give the model my prompt plus the company profile, like whatever is happening in the company. And it was a very long document, and also the tender documents. And then of these, I have to, my model has to predict that should this tender be something considerable or not. And what I faced there was that the context window was being very large. So I was just thinking, we were just discussing pre-fill. Can there be, if anyone has anything in their head, so can there be any method that I make it somehow efficient? Maybe I was thinking the summarization, maybe I should summarize the company profile and the tender document, because I cannot chunk it. I need all the documents to be read, to be analyzed, and a decision should be made on that. So the problem is still there. I haven't solved it yet, but I was thinking maybe what efficient method can I use it to do it.
So you have a bunch of documents and you
Yeah.
need to make a decision whether to follow with a tender or not.
Yeah, and it will be like a lot of text for the model.
Okay.
So is your question as to what kind of architecture you need to build, or is your question more about, which of the existing models I could use to serve this purpose? They're completely two different things.
I think not about the model, because I'm free on the model. I can use any model. But I was thinking, like, it doesn't sound to me like good to give the prompt, the company profile, which will be like a lot of pages, maybe 30 pages, and then the tender document, that's again another very long document. So not the model, I can use any model. I still did it, but it was being very costly, and I was thinking if there can be something efficient or a better way.
Sorry, that's so truthful, because it becomes very expensive, right? If you use like a, let's say, publicly available model, especially when you're processing thousands of PDFs or long context. That's the reason I asked you that question, whether you're talking about the model or not. I think it comes down to, actually, I'm working on an assignment on the same topic at Stanford. So you can drop your email or something, and I can send some documentation to you, which I'm still working on. I'm kind of scared to share it in the public because I might be wrong. The purpose of that workshop and that assignment is to how to economically process long documents and how to protect PII. IDP is one of the hot thing in the AI industry, if I'm not wrong. This is like, I don't have a clear answer, but I know the path to take. So if you want to
Can you
kind
please
of,
share?
yeah, I don't want to share my work here right now, but what we can do is, I don't mind sharing what I have researched so far. I can shoot it to you. You can drop your email or something like that. And once we refine it, we can come back to the group and share our collective findings. Alexei, is it good with
Yeah,
you?
okay.
Yeah, of course.
Okay.
Okay, thank you.
You're welcome.
Samina, I would also suggest that like every time you want to automate something, at least this is the approach I follow, is look at people who do this. Like how exactly do they approach this? Um, so they get this task. How do they explore the documents? How do they find the documents? How do they find the information within the documents? Right? And once you understand that, once you learn from these people, you can then automate it. So I wouldn't just try to dump it. I would just try to model, like at least as the first iteration, I would try to model what people do, like what tools they use to find the answer, what the information they extract. And then once you see this, once you document everything, and I think this is a
Okay.
very important part, like try to document the process. Like if you have like this standard operating procedure of how do you evaluate a tender, then automating it is, I wouldn't say like super simple, but it's more straightforward than doing something else, right? And once you have this
Yeah.
understanding, I think most of the questions you'll find the answers to them. And then you can try optimizing, maybe like doing search here, rack there, or something like that, right? So I wouldn't necessarily try to dump everything because this is not how people do this. Like people don't like they probably follow some approach, right? So maybe the
Yeah,
difficult part
probably.
is like when they already have the information in their mind, right, in their knowledge. Then you kind of have to sit with them and ask like, why did you make this decision? What was it based on? Right? So try to extract this information from them.
Okay. Thank you, Alexei.
Yeah. Okay. Yeah, there are some suggestions about subagents that will also work, right? So like if there is a big document, but you want to extract only certain parts of this document, you can use a subagent for that. That is a very good suggestion. Okay, are there any other questions? It's better if these questions are about the book or the book club, not necessarily about like off-topic things. Because I wanted to talk about the next steps, like how. So first of all, I'll publish the notes for this meeting probably tomorrow. I think I showed you how to find. I'll try to update the interface so it's actually easier for you to find the notes for this. Like what I want to do eventually is that you, when you go to here, the page, book page, we will have notes here, right, for the meeting. Also, if you're reading the book, maybe at least go to this and mark it as read, so then we can see where people are, right? So to understand if we're moving too fast or not too fast. Like you don't have to really fill in the notes, but if you want, we can also do that because I have my notes there, you can have your notes there, and then at the end we can combine this into like one shared set of notes that we can come back to this, right? Well, but at least if you go there and make it as read, should be fine. And then for the next week, I cannot do this on Monday, but I have time on Tuesday next week, so the 25th of August. So our next meeting will be on at the same time, but on Tuesday, not on Monday. And I think my Mondays will be probably busy. Oh no. But anyways, so like you have because you signed up for the this whole thing, like you'll just get a notification that okay, this is the next time we meet. So yeah, that's more or less it. And for the next week, we read the hardware chapter, right? Chapter number 3.
Yeah.
Hi, Jagrut. Yeah, I see that you joined late, but we'll have recording. So it will take me 1 or 2 days to process it, but then there will be the notes that you can check and yeah. But also, like maybe you have some questions. We still have a bit of time we can talk about this. Did you finish chapter 2, Jagrut?
Yes, I read it. Yeah.
Did you start chapter 3?
Yeah, I actually did a quick read of the book like a month
Smart.
back. But it was probably a second reading is warranted. So I'm learning new things as I'm going through it once again.
I think it makes sense because like this is so dense, but when you read, you don't know what are you going to read and what you're going to need in more details to know in more details, and what you can just simply go through and just try to understand conceptually, right? And if you do like the pass is a shallow pass, and then the second pass is like more deep, I think this is a very good strategy.
Right.
Okay, if nobody has anything to add, then we can call it a day for today. So for the next meeting, you'll be invited, and then we read the hardware chapter.
Thanks, everyone. Thank you.
Thanks, everyone.
Thanks, guys.
Goodbye.
Bye.
Thank you.